People often ask me how subnetting is used in the real world. So here are 3 real-life examples to level up your CCNA experience on how to subnet the 4th octet. Let's start with the first of our 3 scenarios. Your network architect calls you up and tells you they are building out a temporary new site. He gives you the 192.168.100.0/27 network and asks you to calculate the individual subnets and their usable hosts. Good luck. The very first thing we are going to do is to ignore everything but what comes after the /, which in our case is the number 27. Let's write out these 27 network bits starting from left to right. When you are done writing out these 27 bits in groups of 8 called octets, fill in any remaining spaces with zeros. As we have 3 network bits in the 4th octet, we need to pad out that octet with 5 zeros. We could speed up this process by using the octet ranges of 1 through 8, 9 to 16, 17 to 24, and finally 25 to 32 to our advantage. Our /27 is clearly going to fall within the last octet range of 25 to 32, so we can start counting out bits in this octet on our fingers, starting from 25 to 27. So 25, 26, 27, and we end up with 3 fingers. We are going to use these 3 fingers for 2 operations. First, to find out the network increment, and later to work out the subnet mask. To work out the network increment, we are always going to use the network increment number range of 128, 64, 32, 16, 8, 4, 2, and 1. For our 3 fingers, start with 128 and stop when you have no fingers left. So, 128, 64, 32. 32 is going to be our network increment for the /27 network. The network increment tells us what the individual subnets will be. If you want to do network increments on your fingers, then learning the network increment number range of 128, 64, 32, 16, 8, 4, 2, and 1 in this order from left to right will make your life super easy and you can work out any increment on your fingers. Now, take the first 3 octets of your original IP address, 192.168.100, and write it down a few times, one under the other. We are now getting into building out our subnetworks in the 4th octet. Why the 4th octet specifically? Because that is the octet where the network 1s ended and the 0s began. This is the only octet where we will change any numbering for our IP address or subnet mask. You may find it helpful to draw an arrow pointing downwards to the octet you are subnetting. 2nd and 3rd octet subnetting gets a lot more complicated, and this arrow will remind you where to place your network increment. The first subnet will always start with zeros, so put a 0 in the 4th octet. Now let's use our increment of 32 in the 4th octet by writing it under the 0. On the next line, keep counting up in network increments of 32 until you reach 256. When you reach 256, you have gone too far and need to cross it out. Each octet has a range of 0 to 255. Some people get confused with this 256. As there are 256 values between 0 and 255, but we can only go up to 255 in any octet. Now you have the maximum number of subnets for a /27 in the 4th octet. Now we have a total of 8 subnetworks when we use a /27 network. Each of these networks have their own range of usable IP addresses that we can use to configure interfaces on PCs, laptops, routers, or firewalls. Each subnet, however, has 2 IP addresses that we can never use for hosts. They are the network IP address and the broadcast IP address. Let's work out the usable IP addresses and broadcast IP address. For our network IP address of 192.168.100.0, just increase the 4th octet by 1 to get your first host IP address. So, our first usable host IP address will be 192.168.100.1. To calculate the broadcast address, we subtract 1 from the start of the next network address. Our next network address starts with 32 in the 4th octet. So, 32 less 1 is 31. 31 is our broadcast IP address. The last host IP address is going to be 1 less than the broadcast address of 31. So 30 is your last usable host IP address for the subnet. You could also try subtracting 2 from the start of the next network IP address to get the same result. Use whichever method works for you. The only gotcha is the very last subnet. The broadcast IP address is always 255. So your last usable host IP address will be 254. So using a /27 network with 192.168.100.0 gives us 8 subnets with 30 usable host IP addresses in each subnet. If we were to use one of these usable host IP addresses to configure a PC or router interface, we would need to convert the /27 into a subnet mask. To do this, we reuse the same 3 fingers that we used to calculate the network increment, but this time we are going to work out the 4th octet subnet mask. To work out the subnet mask, we are always going to use the subnet mask range of 128.192.224.240, 248, 248, 254, and 255. For our 3 fingers, start with 128 and stop when you have no fingers left. So 128.192.224. 224 is the subnet mask for the 4th octet. If you want to do subnets on your fingers, learning the subnet mask numbering range of 128.192.224.240, 248, 252, 254, and 255 in this order from left to right will make working out any subnet on your fingers very easy. Remember, earlier I mentioned that we will only change information in the octet where the network ones met the zeros. Well, we only put the subnet mask of 224 in the 4th octet. Octets 1, 2, and 3 will remain 255, 255, 255. So, our full subnet mask is going to be 255, 255, 255.224 for our 192.168.100.0/27 network. It feels like we just covered a lot, so let's summarize it into 4 simple steps. Step number 1, we only care about the number after the /, and in this case, it was the number 27. We saw this was greater than 25, which is the starting bit of the 4th octet. So, we start counting 25, 26, 27, and end up with 3 fingers. We only make changes in the octet where the ones meet the zeros, so we make a mental note that we will be working in the 4th octet only. Step number 2, we use a network increment number range of 128, 64, 32, 16, 8, 4, 2, 1 to calculate our subnets. We have 3 fingers or network bits in the 4th octet, so 128, 64, 32. 32 is our network increment. We started our first subnet with 0 in the 4th octet and increased it by the network increment to 32 on each of our lines until we hit 256, which we then crossed out. Step number 3, we calculated the first usable host broadcast and last usable host IP addresses for each subnet. Step number 4, as we need a subnet mask to configure any interface, we use the subnet mask number range of 128.192.224.240, 248, 252, 254, and 255. So, for our 3 fingers, we have 128.192.224. 224 is our 4th octet subnet mask. The first 3 octets will always be 255, 255, 255, and we add our 224 subnet mask to the 4th octet, giving us a subnet mask of 255, 255, 255, 224. Let's try a new scenario for you to practice some of your new subnetting skills. You are now on your network manager's radar for all the right reasons this time. She sees potential in you and wants to give you a chance to troubleshoot a network issue. There's a user in HR with an IP address of 10.77.223.37/28. The IT support technician is in attendance and is trying to ping the user's configured default gateway IP address of 10.77.223.49 without success. The company always uses the lowest IP address for the default gateways in each subnet. What is the issue here and how can we fix it? Feel free to pause this video if you'd like to work this out. Now, this one is slightly different. I've given you a usable host IP address in the form of 10.77.223.37/28, and you need to find out which network it belongs to so that we can work out the usable host IP addresses. So, let's dive in with our steps. First of all, we only care about the /28. 28 falls within the 25 to 32 octet range in the 4th octet. Starting with 25, we count up to 28 on our fingers. 25, 26, 27, 28, and we end up with 4 fingers in the air. Next, we use a network increment number range of 128, 64, 32, 16, 8, 4, 2, and 1, and we count down your 4 fingers from 128, 64, 32 to 16. 16 is our network increment. Write down the first 3 octets of your original IP address 10.77.233 and place a 0 in the 4th octet. In the 4th octet, under the 0, count up in increments of 16. Now, in our case, our host has a usable IP address ending with .37. So we only need to know what the subnet IP address is going to be after our .37 usable host IP address, as this will save us some time in writing out all of these subnets. As the network increment is 16, the next subnet after .37 will be .48, and that is where we will stop. Network 10.77.223.32/28 looks like a good place to start working out our first host to last host range. As our network is 10.77.223.32, Our first host will be .33 and the last host will be .46, as this is 2 less than the start of the next network increment of 48 or 1 less than the broadcast IP address of 47. As the host IP address we are investigating is .37, we can see that this usable host IP address falls within the host range of .33 to .46 and is covered by network address 10.77.223.32/28. As a default gateway will be the lowest usable IP address, the correct default gateway should be 10.77.223.33 and not what was configured on the user's PC, which was an error, and it was 10.77.223.49, which is not in this user's subnet. And finally, to work out the subnet mask, we are going to use the subnet mask range of 128.192.224.240.248.252.254, and 255. For our 4 fingers, start with 128 and stop when you have no fingers left. So 128, 192, 224, 240. 240 is going to be our subnet mask in the 4th octet. So our HR user's PC would use an IP address of 10.77.223.37 with a subnet mask of 255.255.255.240 with a default gateway IP address of 10.77.223.33. Let's do a slightly more tricky scenario. Your senior network engineer wants you to investigate a routing issue. A developer is trying to reach a newly built server with an IP address of 172.18.5.228. Their packet reaches the default gateway, but the router drops the packet. The router has the following networks in its routing table: 172.18.5.0/25, 172.18.5.128/26, and 172.18.5.192/27. So, what do you think is the problem? How do we fix this routing table issue? See if you can work it out by yourself. I will put the answer in the comments. Also, what type of IP addressing did I use in all 3 of these scenarios? Look forward to reading your comments. Keep it simple and keep practicing, and you should be able to do 4th octet subnetting with your fingers in about 30 seconds or less, depending on the scenario. One last thing, I'm about to launch a paid community with live coaching, where others just like you are mentored, motivated, and held accountable to fast-track your network engineering career by me personally and your fellow cohort members. Please use the link in the description below to express your interest, and I will personally get in touch with you to see if you would benefit from this program.